Greetings, Spartan fans. Today we're going to talk about solving trig equations. So you should have gotten a note sheet from the substitute. Something that you have to keep in mind, other than you have to know your unit circle, is solving a trig equation is different from finding its inverse. Okay, so there's a couple things. First of all trig functions are cyclical. So for sine and cosine, you have your angle theta, and this 2 pi means that every 2 pi, the graph is going to repeat itself over and over and over again. So I'm just going to draw a really quick parent sine curve. That's the parent, and here's 1, and here's -1. And let's just say that this was pi over 2, and we have pi, and 3 pi over 2, and then 2 pi. And let's say I give you the value of 1/2. The sine is 1/2 here and here. Sine is 1/2. Reference angle would be pi over 6. So you would have two answers. But that's just from 0 to 2 pi. If you were to keep this graph going, well, 2 pi later, you would have those same two answers, et cetera, et cetera, et cetera. So what we're going to look at is just what happens from the interval from 0 to 2 pi. So for all these problems that we go through on this note sheet today, we're just going to look at from 0 to 2 pi. Okay, so number 1 says the cosine of -√2/2. Okay, so I know that the cosine of, let's see, 3 pi over 4, that's -√2/2. And same with the cosine of 5 pi over 4. That's also -√2/2. So if you're looking at the graph of cosine, and the graph of cosine starts at the high point and comes down and then goes back up, and then, of course, on the y-axis, we have 1 and -1. And -√2/2, I don't know. -√2/2 is somewhere here. There are two places where -√2/2 intersects the cosine curve. And it intersects the cosine curve here and here. And those two angle measures are 3 pi over 4 and 5 pi over 4. This is not the same as the inverse cosine of -√2/2. The inverse cosine of -√2/2 is only 3 pi over 4. You are looking at a different function. One is asking you to solve, one is asking you to find the inverse. Okay, so let's look at another one. The number 2 says they want you to find the cosecant is equal to 2. Okay, so remember, you're looking at a different curve. This is not the same as the inverse cosecant of 2. The inverse cosecant of 2, this has one answer. Cosecant of 2 solving has more than one answer. Okay. What it might be easier to do is to take the reciprocal. So I know that the cosecant is 1 over the sine. So if the cosecant is 2, that means that the sine is 1/2. I'm going to erase this and start that over again. If the cosecant of theta is 2, then the sine of theta is 1/2. Those are true statements. Cosecant and sine are reciprocals. So now you got to figure out your reference angles. Okay, so what angle has a sine of 1/2? That angle would be pi over 6. Okay, so that's your reference angle. But sine is positive in more than just the first quadrant. Sine is positive in quadrant 1, but sine is also positive in quadrant 2. So my answers are going to be pi over 6, and then it comes down to knowing reference angles. A pi over 6 reference angle in quadrant 2 is a total of 5 pi over 6. If I asked you for the inverse, the answer would only be pi over 6. You're looking at two different graphs. Okay. All right, let's move on. Let's try another one. So this next one, every example is going to be a little bit different. A squared function. Okay, so if the equation involves a square function, isolate the squared term and then take the square root of both sides. So for example, instead of saying cosine squared, let's say the problem said 4x squared equals 1. Well, to solve that, you would divide by 4, and you would square root both sides, and you would tell me that x is plus or minus 1/2. Okay, but it's not x, it's cosine squared, but the process is going to be exactly the same. So to solve this, I'm going to divide both sides by 4, and I'm going to get the cosine squared is 1/4, and I'm going to square root both sides, and I'm going to say, okay, the cosine of the angle is plus or minus 1/2. Well, that's a lot of places. So the reference angle, so first let's figure out what angle has a cosine of 1/2, and that angle is pi over 3. So cosine is positive in quadrants 1 and 4. Okay, so that would be 1/2 right there. So reference angle pi over 3 in quadrant 1, and in quadrant 4, that would be 5 pi over 3. Okay, that's positive cosine, but cosine is negative in quadrants 2 and 3. So that would be negative 1/2. So a pi over 3 reference angle in quadrant 2 would be 2 pi over 3. And a pi over 3 reference angle in quadrant 3 would be 4 pi over 3. So this problem actually has 4 answers. Okay, let's move right along. Let's flip it over. All right, now we've got this really funky problem. 3 root 2 cosine theta plus 2 equals -1. The goal is to solve for cosine. So to do that, I'm going to subtract 2 from both sides. And then I'm going to divide both sides by 3 root 2. And so now the cosine is going to equal to -1 over root 2, which rationalized is negative root 2 over 2. Okay, so let's figure out what the reference angle is. So the reference angle is going to be pi over 4, because pi over 4 has a cosine of root 2 over 2, but then I got to figure out the negatives. And cosine is negative in quadrants 2 and 3. So if it helps you, let's draw a little picture. Oops, so in quadrant 2, there we go. And in quadrant 3. So a pi over 4 reference angle in quadrant 2 is 3 pi over 4. And a pi over 2 reference angle in quadrant 3 is 5 pi over 4. Okay, moving right along. All right, again, every one of these problems is different. Here we have 2 cosine squared theta equals cosine theta. Never, ever, ever never divide by a function. What happens is you change the degree, and when you change the degree, you lose possible answers. So treat this as if it were quadratic, as if it were like x instead of cosine. So if this said 2x squared equals x, if you divided both, so the degree of this problem is 2, right? 2 answers. If you divide both sides by x, and you tell me that 2x equals 1, you've now changed the degree. The degree went from 2 to 1. No, no, no. Instead, subtract cosine from both sides. And factor. Your factoring life never goes away. I haven't said that in a long time, but it is the truth. If you can't factor with variables, you're certainly going to have a hard time factoring with trig functions. So how would you factor 2x squared minus x? What do they have in common? They have in common an x, so pull out x, and that will leave you with 2x minus 1. Well, instead of pulling out an x, I'm going to pull out a cosine. And that's going to leave me with 2 cosine minus 1. And now I'm going to zip it. I'm going to use the zero product property, and I'm going to say that the cosine is going to equal to 0. And 2 cosine theta minus 1 equals 0. All right, so where is the cosine 0? The cosine is 0 at pi over 2 and 3 pi over 2. And then we're going to add 1. And we're going to divide by 2. Okay, so cosine is positive. This is going to be in quadrants 1 and 4. And my reference angle is going to be pi over 3. Actually, I think we've already done this one. My reference angle is pi over 3. Okay, so in quadrant 1, that's pi over 3. Okay, and in quadrant 4, a pi over 3 reference angle is 5 pi over 3. Okay, so number 5 and number 6 are very similar. They both involve factoring. You can absolutely factor with trig functions. So if it's helpful, which I think for some of you it might be, rewrite this as 2x squared plus 3x plus 1. So let's just pretend that instead of sine squared, let's just pretend that's an x. And let's factor. And then we'll undo that in a minute. Okay, so let's see. What multiplies to 2 but adds up to 3? That would be 1 and 2. Use the zero product property. Okay, but the problem doesn't say x, the problem says sine. So instead of being x is negative 1/2, the sine is negative 1/2. And instead of x being negative 1, the sine is negative 1. You can't actually just straight up factor using the trig functions. I'll show you that in a second. So where is the sine negative 1/2? Okay, so the reference angle is going to be pi over 6, and sine is negative in quadrants 3 and 4. So that's going to be 7 pi over 6 and 11 pi over 6. And sine is negative 1 at 3 pi over 2. Okay, so if you need help with that, sine is y, so right here, 0, negative 1, that's 3 pi over 2. And then going back, the inverse sine of negative 1/2. So sine is negative in quadrants 3 and 4. The reference angle is pi over 6, so all the way around, that's 7/6, and then all the way around is 11/6. You can just straight up factor using the trig functions, which is I tend to do. So this would factor as 2 sine plus 1 times sine plus 1. Notice that when you distribute this, this would be 2 sine squared plus 2 sine plus 1 sine, which is 3 sine, and then plus 1. So there's absolutely nothing wrong with doing the straight up factoring using the trig functions. Okay, last one. This last one involves us going back and remembering what some of our identity functions were. Okay, your best bet is to try to do a substitution using secant squared. All right, so way back when, we said that sine squared plus cosine squared was equal to 1. I know this was like eons ago, and if you don't remember it, I totally understand. There is a variation of this function that says if we were to divide everything by cosine squared, that would yield tangent squared plus 1 equals secant squared. Okay, so how I got that was sine over cosine is tangent, cosine over cosine is 1, and 1 over cosine squared is secant squared. All right, so have to really go back and remember that sine squared plus cosine squared is 1. It's the primary trig identity. Well, now I know what secant squared is. And so what I'm going to do is I'm going to take this equation right here, and I'm going to take out secant squared, and I'm going to substitute in and say, well, secant squared is the same exact thing as tangent squared plus 1. So I'm going to do a substitution. And so I'm going to say tangent squared plus 1 minus 2 tangent is equal to 0. And I'm going to rewrite this so that it's quadratic. I'm going to rearrange the terms, and I'm going to factor. Okay. If it helps you, instead of writing it as tangent squared minus 2 tangent plus 1, write it as x squared minus 2x plus 1, and factor using x's. I'm going to use tangent. So you can factor this as tangent theta minus 1 times tangent theta minus 1. If you have poor factoring skills, got to come in for help. Or if you want to just do it with x's, you could say that this is x minus 1 times x minus 1. But instead of x, it's really tangent. Zero product property. And you get the tangent of theta minus 1 equals 0. You get it twice, so we're not going to worry about that. I'm not going to write it twice. So now it's going to be the tangent of theta equals 1. Okay, so got to figure out your reference angle. So first of all, tangent is positive in quadrants 1 and 3. The reference angle is going to be pi over 4. I know I'm a broken record, but if you still are having a hard time figuring out what the reference angles are, you've got to make note cards. If you always have to draw out your unit circle, it's going to be very difficult. Okay, so pi over 4 in quadrant 1 is pi over 4. And then pi over 4 in quadrant 3 is going to be 5 pi over 4. And that is solving trig equations.